So for question 10A, it says write 25 as a binary number. So binary numbers are like ones and zeros, just like you see here. The first thing we do is we work out with 1 on the right hand side and we multiply by 2 to each one. So 1 times 2 is 2, 2 times 2 is 4, 4 2s are 8 and 8 2s are 16. Now the next one is 32, but it's a bit too big for 25, so we want to keep it at 16 here. The first thing we do is we put a 1 at the 16 and then we find out how many is left out of the 25, which is 9, and then we put 1 at the 8 and 1 at the 1, so these all add up to 25. So what you should have is 1 at 16 and then we have 8 and 9. If you add all the ones up here, that would be 25, and we fill in the rest with zeros, and that should be your binary number. Write the binary number 1101001 in decimal form. So the first thing we do is we start with these numbers just like question 10, is we have 1, 2, 4, 8, 16, 32 and 64, and we have our binary number underneath here, so make sure it fits. So we've got 1, 2, 3, 4, 5, 6, 7 and 7 numbers up above. So we look at where the ones are and we get the values of ones. So we've got a value of 64 here for that one, value of 32, value of 8 and a value of 1. We just ignore these zeros here, and what we do is we just add those values up and it should be 105. Next question says make M the subject of the formula. So this is what I've done here, is basically I've swapped this around. If H is equal to MR plus S, then MR plus S must equal H. So all I've done is just swapped it around, and then I've just taken away S on the left hand side, but also on the right hand side here. So that gets rid of the S, and we divide with R both left and right hand side of the equal sign. So what you should have is M equals H take away S over R. Question 12 says two fair dice are rolled. Make a list of all the ways it's possible to get a total score of 7 on the 2 dice. So this is what I've written here, is you can have 1 plus 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So the first number would be your first dice and the second number would be your second dice. So these are the numbers that you would come up with. So for question 13, this line here, it's a negative gradient, has already been drawn for you. And this is a negative gradient, so that's one thing to look out for when you're doing these kind of questions. So if we move on to the next page, you can see they're giving you two equations, so they haven't told you which equation was for that line, but you can see this second equation here has a negative gradient, so you know that that line on the previous page would correspond to that equation here. So now we're going to be looking at y equals 2x minus 2. We're going to have to draw that line. So if we go into the previous page again, we draw a table here, x and y table. We fill our values of x up first. We can take that from the graph. You can see minus 2, minus 1, 0, 1 and 2. That's what's been put here. Then we can work out what our y values are. By doing that, we can take our equation and we just replace the minus 2 where the x was. So that just means 2 multiplied by x, take away 2, and this is what we do with the minus 2. So it's 2 multiplied by minus 2, which is minus 4, take away 2, which is minus 6. And that's how you get your values here. So that would be 2 multiplied by minus 1, which is minus 2, take away 2 is minus 4. 2 multiplied by 0 is 0, take away 2 is minus 2. So that's kind of how we get our values. Then we use these values to plot our graph. So you can see -2, -6. So -2, -6, you can see that goes off the graph. So then we move on to the next one. -1, -4, -1, and -4, and we plot our point. We have 0, -2, so 0, -2, plot our point. 1, 0, so that's 1 across, 0, that goes there. 2 and 2, 2 across and 2 up, and goes there, and we draw our line. Now to find the solution to this, we need to find the coordinates of where they cross. So we need to find the x value of it, so we look at the x-axis, and we find out where our x value would be, and we find where our y value would be here. And if we look at the next page here, you can see that x is going to be 0.8 and y was -0.4. So for question 14, it says find the value of -2 in brackets with a power of -2. So what you want to make it, this power of -2 a positive power. So the way to do that is you could put it over 1 over. And what I've done here is 1 over and then -2 in brackets with the -2 inside, and the power has actually gone positive. So that's how to change it to positive. You would just do it 1 over. And then it's -2 squared. Because this is in brackets, then it's going to be -2 multiplied by -2, which then becomes 4. So the final answer there should be 1/4. For question 15, it says make x the subject of the formula y equals b over the square root of x. Right, so what I've done here in the steps is I've brought this square root of x across, and you have to multiply with the square root of x on each side, or know that that's a division there between the b and the square root of x. When we bring the square root of x across, it's the opposite of a division, which is a multiplication. So that now we've got y multiplied by the square root of x equals b. We want to get rid of the y on this step, so we bring the y across. Instead of it multiplying with the square root of x, we think of the opposite of that, and it's a division. So when we bring the y across, it becomes a divide. So square root of x equals b divided by y. Next, we want to get rid of the square root, so we're still thinking in opposite, so we're moving the square root across, which becomes a square. So the opposite of a square root is a square. So we've got x, and we square everything on the right hand side. And now we've got b over y in brackets squared. And to finish off, we can actually square top and square the bottom of that fraction. So we've got x equals b squared over y squared. And that should be the final answer. So question 16 says, on the grid, draw a reflection of the shape w in the line y equals -x. So for the line y equals x, it would be a positive gradient all through 1, 1, 2, 2, 3, 3, 4, 4. When it's y equals -x, it's going in the opposite direction. It's a negative gradient. And you can see it there. It's going -1, 1, -2, 2, -3, 3. So that's what you would have as y equals -x. It has to go through the origin, or 0, 0. This one here, you can use a ruler if you wanted to. You could use anything like that, or you could just count diagonally to the line. So that one is 1.5, and that will be a half and 1, and that's where your point would be. So you can do that with every point. Just go diagonally to the line, or you can take each point and just count to the line and down. So you go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's a few different ways you could do this. You could take each point and work like the bottom one here is 1, 2, 3 across, and that'll be 1, 2, 3 down. You can do that with every single point on that shape. Okay, question 17. This is a bit of a wordy question for 1 mark. So there are 3 main routes from Balleek to Enniskillen by car. There are 5 main routes from Enniskillen to Fintona by car. How many different ways can James travel from Balleek to Enniskillen to Fintona by the car using only main routes? So we have 3 times 5 equals 15. This is because there's 3 main routes from Balleek to Enniskillen and 5. So 3 multiplied by 5 would give you 15 different ways he can travel. So question B, on a particular day, 2 of the main routes from Enniskillen to Fintona were closed. By what percentage has the number of different ways for James to travel from Balleek to Enniskillen to Fintona by car using only main routes being reduced? So being reduced is the main thing. Here you can see what is it being reduced by. So it says 2 of the main routes from Enniskillen to Fintona were closed. So this is it. The main routes to Enniskillen to Fintona were 5. So you can see 2 of the 5 routes were closed. So it's been reduced by 2, really. So 2 of the 5. If you multiplied that by 100, you would get your percentage, and sometimes you can see that 2/5 would equal 40%. And that's your answer for that one.